Okay, for the multiplication rule, we're dealing with whether we have independent events or dependent events. Okay, so independent events are two events if the occurrence of one does not change the occurrence of the other one. Okay, so when they're independent, we're just going to multiply. So anytime we're trying to find the probability of two events occurring at the same time, we're going to multiply their probabilities. Okay, so I like to use the example, and then dependent events are when the probability of one changes the probability of the other, and we use something called conditional probabilities. Conditional probabilities we write as the probability of A given B. So this line we read as the word given. Okay, so a good example of this is when we draw cards out of a deck. Okay, and whether we replace them or not replace them. Okay, so think about it. If you have a deck of cards in front of you, okay, and I say, what's the probability that you draw out? Okay, so we all know there's 52 cards in a deck of cards. Standard deck of cards has 4 suits, 13 in each suit, so that's 52 cards. Okay, what's the probability of you getting a king? Well, you would tell me the probability of getting a king, because there's 4 kings in my deck of cards out of 52 cards, right? So the probability would be 4 out of 52. Now I say, okay, here's a second event. I want you to draw a second card. What's the probability you get a king again? Well, let's say after you drew it the first time, you put the card back. So you still have 52 cards, right? Okay, so the second time drawing the king, I'm going to say with replacement, meaning you put the card back, right? It's still 4 out of 52, right? Because you put that card back. Because there's still 52 cards, and there's still 4 kings. All right, so now let's change my experiment a little bit here. And let's say you drew the card. I give you the deck, you draw the card. The probability of getting a king. Probably should have put probability statements on here so you're used to it. Okay, the probability of getting a king. Okay, you would tell me is 4 out of 52, right? I'm going to put a little 1 with this king because that's the first draw. Okay, so now let's say without replacement, meaning you keep the card that you draw out. Okay, so now the probability of getting a king on your second draw, given, that's where this conditional comes in, you got a king on the first draw. Okay, so it's making, this given is almost like making an assumption. Okay, think of it that way. So if I assume that you got a king on the first draw, how many kings are left? Well, there's only 3 kings left, right? And how many cards are left? 51. So now your probability is 3 out of 51. So when we don't replace the card, it becomes a dependent event, because the probability of the first event occurring changed the probability of the second event, where the probability of the second event used to be 4 out of 52 when it was independent, because we put it back. It didn't change the probability. Now that we keep the card out, it changes the probability. Okay, so let's go back and look at these then. For independent events, if we roll 2 dice, what is the probability of rolling a 4 on both dice? Okay, so now you want to think about it. A is rolling a 4 on the first die, right? And B will be rolling a 4. Sorry, my pen's not working here. On second die. Okay? Now, rolling the four on the second die, does that change the probability of the first die? It does not. So this would be probability of A times probability of B. Or we can write it as probability of 4 times probability of 4. So that would be 1/6 times 1/6, or 1/36. Right? Okay, what about if we flip a coin and then roll a die? What's the probability of getting heads and a 5? Are they independent of each other? They are, because whether we get heads or tails doesn't change the probability of whether we get a 5 or not. So this will be the probability that we get heads on the coin times the probability that we roll a 5. So we have 1/2 times 1/6, or 1/12. Now, all of these you can write as a decimal as well. What about probability of tossing the coin and getting tails and getting an even number? Again, the flipping of the coin does not change the probability of rolling the die, so they are independent. So we multiply the probability of getting tails times the probability of getting an even number. So tails is 1/2. How many even numbers are there in a die? 2, 4, and 6. So again, that's 3 out of 6, or 1/2. So we get 3/12, or 1/4. Make sense? Okay, so in some of the homework, it may actually ask you to actually determine if they're independent. And so in determining if they're independent, oops, sorry about that. You would actually want to show sorry about that. If the probability of A equals the probability of A given B. That would show you that B occurring does not change the probability of A. Okay? So I have that right down here. This is how you would show if they're independent events. So if the homework asks you to do that. Okay, so compute the probability of drawing 2 cards from Welsh. Okay, so we did that already if one is not replaced. Okay? And that's the addition rule.